Hello, could you tell me a bit about yourself?
Yeah, I'm Swami. I'm a senior principal researcher at Lila Sciences. I lead most of our core AI research directions, including post-training, reinforcement learning, and agentic pipelines as well. So I've been at Lila for a year and a half, and before that, I worked in computer vision to start off my career, and I worked in a startup with healthcare, launched products, and I worked in AI ethics and interpretability as well. I do believe science is the next biggest AI frontier. That's why I'm here at Lila.
So, are you at Lila approaching the sciences all together? So, physics, biology, chemistry, like you believe that all of these things can be solved together?
Yeah, that's a great question. We, at least at Lila, we do believe that the right level of abstraction, we can orchestrate solutions that span the entirety of sciences. So one of the it's not just a thesis that we have put things into action as well, where we actually have constructed AI science factories or like programmable labs, which can be essentially used to compose different scientific experimentation workflows. So our hope is like we can have our agents discover new protocols or new hypotheses by interacting with this scientific world and actually learn from experience.
Could you tell me a bit more about one of these labs and what it actually looks like to use it?
The scientific labs are essentially looking like, they don't look like robots, but they look like kind of like machines that are connected with like rails and platforms, and things move between them and they pass messages, and they essentially expose like a API which can be controlled, and they also give out like data and things like that we can read out from required output sensors and stuff like that. This will be used by any kind of like predictive model based system. So may it be LLM, may it be some other advanced reasoning model or your agentic system, it doesn't really matter. But the output that comes from these essentially programmable labs, you can think of these as like almost like cells that have machines that are cased inside them. And then we can essentially, the interaction between the agent or any kind of like system, I do say agent, but like I mean basically a agentic system, can then interact with these like labs using essentially computer commands.
I see. And where is the kind of scientist in this loop? Or is there no scientist?
So the scientist is there in the loop in a lot of different parts. So constructing just the automated lab and the workflows, like there's a ton of scientific help that we take at Lila. Lila is actually incubated from Flagship Labs, which is a science-first company. They also incubated Moderna and other companies. So actually, if I'm not wrong, scientists almost equal or outnumber software people in Lila. And we take our science experience very seriously. We sit in the same room as scientists who actually run campaigns, collect data, let them inform every step of the process in terms of like how to compose workflows, how to go for like different targets that we want to solve for, and things like that. So I think science is like very science and scientists, human scientists are very essential part of our whole framework.
What do you think is the most ambitious problem to you that can't be solved without programmable labs?
That's an interesting question. That might be a limitation of my scientific abilities, basically what you're asking. I would say maybe there are things that we might not be able to realize in like real organisms. So for example, like there can be expressions and things like that of protein molecules that can differ based on like where they exist. Like if they exist in a cell or if they exist in human, the way that they express themselves differ. So I think maybe that level of sophistication we will like continue to build towards. There are a lot of companies that do like virtual cell experiments and stuff like that. So we'll probably be using some of those technologies as well going forward in the future. So in terms of programmable, it's not necessarily a limitation, but it's something that maybe it will come over time in the future.
What's the research direction that you're working on right now that you're most excited about?
Yeah, absolutely. Great question. So our core AI research team at Lila is really interested in understanding what is scientific superintelligence, how can that emerge, under what conditions can it emerge, and you've probably heard like the word inductive bias and things like that across the field at NeurIPS. So we are trying to like find those right inductive biases for this emergence of intelligence. And when we say emergence, we kind of try to characterize it by breaking it down into different concepts that we can operationalize, generalizability and transferability being key components of it. So what we want to really understand is, if you take essentially a chemist who is an expert in like a bunch of different topics, quantum chemistry and all of that stuff, and put in a room of biologists, how far then can they hold their own? That's kind of like cross transferability between areas of science is something that we are actively trying to explore in our AI research team, and in combination with other domain-specific teams as well.
That's really interesting. Can you tell me about any discoveries you've made on that front, or is it under wraps?
It's a little bit under wraps.
Okay.
We have made a lot of like public articles available, where in terms of maybe not the specifics, but like we have done like several discoveries across the realm of science so far. And even in the AI research side, we have actually observed a lot of recent results, pretty much more than what essentially the frontier can do at this point. So we are really excited to share this with the world, but we just want to have the right framing, and we want to have, more than that, we want to have the right wedding. Like, we want to be appealing to the scientific community as well, and we want to be as precise as possible, and not, definitely like over promise and under deliver, but we want to be like really careful in like how we are claiming what we have achieved and what we have not achieved. Because I think, I don't want to comment on either companies, but like definitely the scientific world requires rigor. And at Lila, we really want to like take our time in like making sure we are rigorous when we are coming up with the evaluation process.
That makes a lot of sense. So what do you think is your ideal vision for how Lila and real world scientists are going to collaborate in the future?
Yeah, that's a fantastic question. I cannot speak for Lila at this point. I can only speak for myself, because I don't know where the world is going to be in 10 years. But I would say, I think I would imagine that, like, as a scientist, like, I have friends who are chemists, who are biologists, and they spend a lot of time in their lab, like coming up with experimentation, ablations, experimental protocols and stuff like that. One of those things that will be easier is if they can actually like attach essentially an automated framework that can do a lot of the automated work for them, so that they can focus their time on actually like taking those results and like coming up with like newer approaches or newer assets or newer molecules, something like that. And for example, if you have like pandemic in the hope we don't, but if you have something like that, what is the fastest way in which we can actually like get those strains and get a vaccine out the door? Yeah. And if we can have 10,000 agents in parallel working 24/7 so that we can actually like save lives that way, that would be fantastic. I mean, ideally, like that would be a mission, like my vision. But again, like I'm still learning science as I go. Like my science was like at like kind of like middle school level when I joined Lila. It's been a year. Now I'm like high school level, maybe. But hopefully I'll graduate soon.
Absolutely. Well, thank you so much, Swami. This was really interesting.
And of course, yeah. Thank you so much for the opportunity. And thanks for amazing questions.